So let's take a look at integration by partial fraction decomposition. So looking at the integral of x minus 13 over x squared minus 5x minus 6, the two biggest indicators for when you should use partial fraction decomposition is when your fraction is bottom heavy, so the highest degree of the denominator is bigger than the highest degree of the numerator, and when you can break the denominator of the fraction up into factors, linear factors. So if I were to break the fraction up, or the denominator of the fraction up into linear factors, I get x minus 13 over, I need something to multiply the negative 6 and add the negative 5, and that would be x plus 1 times x minus 6. So now what I'm going to do is step away from the integral for a moment, because all we're trying to do is break this fraction up into two smaller fractions. So the first step is I'm going to have to set this equal to a constant a over one of the factors, so I put x plus 1, plus another constant b over the other factor, x minus 6. Because I know that by the time I decompose this fraction, it's going to be broken down into two smaller fractions. So I just rewrote this entire thing down here. So the next step we need to do is to be able to multiply both sides of the equation by x plus 1 times x minus 6. So let me just squeeze that in here. So when I do that, it'll cancel out the denominator. So the x plus 1's will cancel, and the x minus 6's will cancel. So on the left side of the equation, I'll get x minus 13. And on the right side of the equation, since there's a plus here, I can actually distribute those factors to both of those fractions. So I can rewrite this as a over x plus 1 times x plus 1 times x minus 6 plus b over x minus 6 times x plus 1 times x minus 6. So the x plus 1's will actually cancel, and for b, the x minus 6's will cancel. So if I were to rewrite this down here, I get x minus 13 equals a times x minus 6 plus b times what's left, which is x plus 1. So now what I need to do is plug in a value for x that will cancel out one of the terms and solve the other term. So let's just start with a here. If I plug in negatives, or if I plug in 6 here, 6 minus 6 is 0, and that would actually cancel it out. So let's say I say x equals 6. So then I'll get 6 minus 13 equals a times 6 minus 6, which is 0, plus b times 6 plus 1, which is 7. 6 minus 13 is negative 7. A times 0 cancels. We get negative 7 equals 7 times b, which is 7b. So now I can just say b equals negative 7 divided by 7, or negative 1. So I'm just going to put that off to the side here, where b equals a negative 1. And a is in a certain value. I can figure that out later. So now what I'm going to do is find out what a equals. So I'm going to plug in something for b that will cancel b out. And so if I plug in negative 1, negative 1 plus 1 is 0. So when x equals negative 1, when we plug in negative 1 for x, we get negative 1 minus 13 equals a times negative 1 minus 6, which is negative 7, plus b times negative 1 plus 1, which is 0. Negative 1 minus 13 is negative 14, equals negative 7 times a, which is negative 7a, plus b times 0, and that just cancels. So now that I've isolated a is going to equal negative 14 over negative 7, which is 2. So I can write that up there. So now what I can finally do is plug these values back into these two fractions. So since a is equal to 2, I get 2 over x plus 1 plus b is equal to negative 1, so I get negative 1 over x minus 6. And I can actually distribute the negative out front, so I get 2 over x plus 1 minus 1 over x minus 6. And this is what it looks like when I have broken down this fraction of x minus 13 over x squared minus 5x minus 6. So now that I've broken it down, I can actually put this under the integral because I've rewritten my fraction. So I get the integral of 2 over x plus 1 minus 1 over x minus 6 dx. Since there's a minus here, I can actually make this, or split it up into two integrals. So I get the integral of 2 over x plus 1 dx minus the integral of 1 over x minus 6 dx. And now this is pretty simple because I can just use u substitution. So let's just start with the integral of 2 over x plus 1. If u equals x plus 1, then du is just going to equal 1 dx or dx. And when I sub that in, I get the integral of 2 over u du. The 2 can come out front, and I get 2 times the integral of 1 over u du, which is just 2 times the natural log of the absolute value of u, and u is equal to x plus 1. And now with this integral here, the integral of 1 over x minus 6, same process, u equals x minus 6, so then du will equal just 1 dx or dx. When I plug that in, I get the integral of 1 over u du, and that's just the natural log of u, and u is equal to x minus 6. So now that I've integrated, I can just take what I have here, what I've just found here, and I need to include that minus sign here. So the final answer is going to be 2 times the natural log of x plus 1 minus the natural log of x minus 6 plus c.